All right, I'm going a little crazy. I just messed up making this video like 4 times. It's been an hour. I've gotten nowhere. In good news, it does look like Georgia's pulling for Biden. If you haven't figured it out yet, I'm rooting for the Democrats. Uh, so the race might be over in America. In the meantime, we'll Biden our time talking about equilibrium. So far, what we've thought about in this course. Let's take a little recap. We looked at first the consumer side of the problem. The consumer side said a consumer walks into a store, has some income in her pocket, looks at the prices, and decides what is the bundle of goods that can maximize my welfare, right? Maximize my utility. And that comes from her taking prices as given. She walks in the store, she sees the prices. The prices are a parameter. They're an input to her optimization problem. They're not a choice variable. She doesn't set the price. She takes the prices as given. We call this price-taking behavior. And then from that price decides to optimize her behavior and choose what to do to maximize utility. On the other side, then we studied production, and we said, well, the producers, they take costs of inputs and the price of the output as given, and then from that construct some optimal input demands that create through this technology an output, so they decide the amount of output to produce. That's called the supply function of the firm, Q star, and that thing was taking prices as given, right? They took the price of the output, the price of the sale, the thing that they're going to sell, as given. So they were also doing price taking, or they were price takers. And so this leaves us in this sort of mysterious, underdefined world in which the consumers aren't setting the price and the producers aren't setting the price. So who is setting the price, right? When we look at real markets, we see stores set a price. We see that sometimes consumers set a price on, like in an auction. The consumer's the one saying how much they're willing to pay. So in different kinds of markets, you see different kinds of price construction, like literal price construction. But the question is, where are these prices actually being determined? How are they being determined, right? How does the store come up with its price relative to the price of other stores or whatever? Why is the price of beans so consistent across different stores? So we're going to do that in a few steps, and the first one is going to be defining partial equilibrium. And the partial in partial equilibrium refers to, we're going to look at one market at a time. The market for beans, the market for apples, the market for whatever. And of course, the market for apples depends on the price of pears, right? Things like the price of pears determines the demand for apples, so there's going to be some kind of like feedback loop where if the price of one goes up, then whatever, right? And that seems complicated, and we're going to have to develop tools to deal with it. And so for now, we're going to talk only about one market at a time, hence the partial and partial equilibrium. And we're going to let income and costs of inputs and all that stuff still ride as being exogenous, being as parameters that are not chosen. In the full-fledged dynamic general equilibrium, that will not be, there really will be pure endogeneity. Everything will be determined in the model. So this is what I just said. How are we going to do this? Well, we're going to think that there's n different consumers, right? So it's not one guy anymore. It's a bunch of consumers. They are indexed by I. So I runs from 1 to n. So 1, 2, 3, 4, blah, 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 n. I is just a point in there. And x star I is the demand, the Walrasian demand of the ith consumer. And she faces price vector p. And she doesn't choose price vector p. Price vector p is given. And she has an income I of I, which is her specific income, right? So I walk into a store, there might be a richer person, there might be a poorer person, we all face the same prices. So prices are common, the price vector is common, the income is idiosyncratic, it depends on the consumer. So it's indexed by I. Now we can define for each one of these a Walrasian demand, right? This is a well-defined problem, it's an income and a price. We assume that there's also a utility function, which could be individual, depend on different consumers, so the utility depends on I. And what we get is x star I, which is the demand of the ith consumer. And then we could just sum that up, right? So how many apples are demanded? Well, it's the demand for the first consumer plus the demand for the second consumer plus the demand for the third consumer, etc. And so the market demand is just the total demand across each of the n consumers, right? And so we're just going to sum across all of the consumers. They face the same price. They have their own utility functions, their own incomes. We do the same thing for production, on the production side. So there's J 1 through M consumers. So J goes from 1, 2, 3 up to M, and there's a bunch of consumer producers. Each one of them has their own technology, but they face the same prices, right? So they face the same cost for inputs and the same price for the output. And from those that price cost parameter set, they choose how to maximize their profit. They optimize by choosing the correct supply, demand of inputs, and that yields some output according to their production technology. We sum across all of the different firms. So how many apples are in the market? Well, it's how many the first farmer produces, plus how many the second farmer produces, plus how many the third farmer produces, up to the nth farmer. And so we have a market supply, which is a function of the price and cost vector, and it depends on the technologies of the particular people. So the supply curve, which is just the sum of a bunch of individual firm supply curves, is upward sloping, right? If you have a bunch of upward sloping functions, you add them together, it's still upward sloping. That's the law of supply, right? It came from the convexity of the profit function and the fact that the supply function was the derivative of the profit function. So you take the derivative of the supply function, you get the second derivative of the profit function. Second derivative of a convex thing is positive, which means the first derivative of the supply function was positive, which means it's upward sloping, right? That's the definition of upward sloping, it has a positive slope. So that was where we got the law of supply from. It came from properties of the profit function, the optimal profit function, which we derived in detail in the previous lectures. The demand curve, however, does not have such a nice property, right? There is no law of demand for Walrasian demand. There's a law of compensated demand for Hicksian demand. But we're not dealing with Hicksian demand, we're dealing with Walrasian demand. Remember that Giffen goods are ones where there's such an extreme income effect in the opposite direction of the substitution effect that an increase in price actually increases demand because they're extremely they're like necessity goods that are substitutable from some other good, right? The bread and meat example from Giffen, and we can't rule out the possibility that our model doesn't predict that when you increase the price, demand necessarily goes down. Now, for the rest of the course, we're going to assume that when price goes up, demand falls. We're going to assume a downward sloping demand curve, but it is worth pointing out that this is not an assumption that comes from, this is itself an individual assumption, right? It doesn't follow from more primitive assumptions we've already made. The law of supply follows from the assumption of profit maximization. Profit maximization implies the downward sloping, the upward sloping demand curve, supply curve, my God. Nothing about utility maximization implies the demand curve is downward sloping. So that is what I mean by this is an additional assumption. It's not riding in through more primitive assumptions on what the consumers are doing. Now let's think about what happens if the price is such that the demand is higher than the supply. We call this a situation of excess demand. So I set a price for apples. At this price, consumers demand 15 apples and suppliers supply 12 apples. That means there's an excess demand of 3 apples. There's 3 people who want an apple, or there's 3 apples demanded across the consumers that aren't being supplied, right? So what would happen? Well, in the short run, firms could just increase their price, right? Firms could increase their price means that they could sell the same amount of apples. They'll still sell their 12 apples, but they'll make more profit. Now, how can they increase their price? Well, they can increase their price because that decreases demand, but it doesn't decrease sales because there's more demand than there are sales. So you can keep decreasing your demand until you hit that barrier of 12, right? You erode the demand, but that's fine because those people couldn't afford, there was no apple for them to buy anyway. So in the short run, prices can adjust because the suppliers can change their price. Or in the long run, maybe new firms enter the market because there's a higher demand, there's room for a new firm to enter the market. That's going to shift the whole supply curve up, and so then the supply curve changes at the given price, right? So if there's new firms, that changes the entire market supply curve. So the supply curve could shift in the long run. On the short run, we're going to move along the supply curve by changing the price. In the long run, we can shift the supply curve by changing the composition of firms in the market. So the opposite logic holds if the price is such that the supply is higher than the demand. We call this excess supply, unsurprisingly. So excess supply is a case where the price is such that 15 apples got supplied and only 12 got demanded. Well, now there's 3 apples sitting on the shelf that some firm has, and they can't sell them. And so in order to sell them, they have to lower the price on those apples, right? So that means that the price in the short run will fall if they want to sell, if they want to move their inventory. In the long run, there's too many firms. Some of them might go bankrupt, so some of the firms will leave, and that means that the supply curve itself will shift because the composition of firms will change. And so remember, the supply curve is just the sum across individual firms. Some of those firms enter or leave, there'll be a movement in the entire supply curve, right? Because we're summing over a different set of firms. So in either case, there's a sort of a push, a market force, which pushes towards moving demand towards what the moving supply towards what demand was, or moving demand towards what supply was, shrinking the gap between supply and demand. That leads us to this notion that in the long run, we should expect to see something called equilibrium. Equilibrium means the forces are equal, everything's in balance. The supply and the market are going to be, the supply and the demand in the market are going to be equal. So an equilibrium is a case where the quantity supplied and the quantity demanded for a given price are equal. An equilibrium is a property of prices, right? It's a property of the demand functions, but the equilibrium given the demand and supply functions is a price. So equilibrium is a notion of prices. An equilibrium price has equal demand and equal supply so that there's not excess demand nor is there excess supply. And of course, in a given situation, you might expect there's tons of weird little micro fluctuations, right? Prices of inputs change unexpectedly, demand changes unexpectedly, there's a recession, there's some spoilage, there's a plane crash and you can't get your supply or whatever. All sorts of reasons why in a given snapshot, you're not going to see supply equal demand, right? In a given moment, you're not going to see supply equals demand. This is not a notion of, this always holds all the time. This is an idea of we're abstracting away from these problems, these like individual short-run problems, and we're thinking about in the long-run average behavior, we should see supply equaling demand. Because if the supply was systematically over long periods of time higher than the demand, then we should see the price change to reflect that, right? So the price should move down to increase demand and decrease supply. Or if the opposite was true, we should see the price increase to decrease demand and increase supply. And so this is a long-run idea. We're not modeling it that way. We're modeling it as a snapshot, but the intuition is from the long run, right? Where things can adjust, and it's not one of individual moments in time. It's one of averages. It's one that says, on average, we should see this property holding. So if you're interested in this, there's 100 years of people thinking about, how to actually think about aggregation over time, how to think about aggregation over different stores and things like that, how to get like individual profits and blah, 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 blah. So believe me, this isn't a deficiency in economic thought. It's a deficiency in what we can teach in an intro class, right? So we're going to take the simplest approach where we just say supply equals demand, and we're not going to worry about the fact that there's all these other assumptions baked in, that how does supply equal demand, etc. So here's a little picture of what happens in these different versions of the world, right? So in the left-hand box, we have excess supply. So first of all, the blue line is the demand curve, right? It's downward sloping in the sense of in order to affect a certain demand, so in order to ensure that you're going to sell exactly a certain amount, the more you want to sell, the lower the price has to be, right? So that the blue line is going down. So the higher the demand you want to induce, the lower the price is that induces it, right? So that's a downward slope. And now we see that my original little tirade about how the price is on the y-axis, even though it's an independent variable, the price is not really the independent variable. These are co-determined. Price and quantity are co-determined through this relationship of supply and demand. There isn't necessarily an independent and dependent variable. So we're thinking about the quantity as being the in some sense the dependent variable, but it's equally valid to think about it the other way. If I want to sell exactly X units of the good, what price do I have to sell it at, right? And so the larger the amount I want to sell, the lower the price has to be. The exact inverse logic works for supply. The more I want firms to supply, the higher the sale price has to be, right? So that means that the supply curve, the red curve, is upward sloping. The larger the supply in the market, the higher the price has to be to sustain that supply, because firms will find it less. I mean, that's just the law. That's just the law of supply. So what happens if we have excess supply? That means we're setting the price higher than the equilibrium point where these curves cross. So we have these two dots that are above, that are way up north, and the supply is much higher than the demand, right? So the quantity supplied is much higher than the quantity demand. That means there's excess, there's a surplus, there's excess of this good sitting in a warehouse somewhere not being sold. Well, what happens? That means we're going to have to lower the price. These firms that can't move their product have to lower the price. This lowers the price towards this equilibrium. On the right hand, we have the opposite thing happening. We have a shortage, right? And this would be where there's excess demand. The price is too low. Firms don't find it valuable enough to supply in high numbers this product, but because it's so cheap, lots and lots of people demand it, right? Which means there's tons of consumers who don't have access to the good, right? They are willing to pay more than they actually have to pay, which means that over time, these firms that are supplying it could raise the price, right? So that's going to move the price up. So you see that if there's excess supply, the force moves the price down. If there's excess demand, the force moves the price up. This force is sort of like the invisible hand, right, of the market. It's not a literal force, but it's the incentive of the people who are literally setting the price. We don't really care. It could be consumers, it could be producers, but the incentive is to move it in the direction of making supply equal demand, because that's, think about a shortage, right? Like when a new iPhone comes out, the price is too low in some sense because there's consumers who are willing to pay more than they get, right? And what happens is that people buy the phone and then they resell it on the internet for a higher price, and that moves the market price for this phone upwards. And you see that there's this resale market. Now, this has a bunch of other things because there's not free entry and exit, so it's not exactly a competitive market. But the idea is the same, that it's actually the consumers there setting the price. They're willing to pay more on eBay, and so the price moves up towards this equilibrium price. So there's lots of to study right here, but the general idea is that the force, whatever it is, from the consumer side, from the producer side, whoever's actually making these pricing decisions, the force is always in the same direction, towards equilibrium. And so we don't really have to worry about who's actually making the determination. The point is that the market, the supply and the demand curves is going to determine this price, the equilibrium price. So let's do a little example, right? So the market supply as a function of price is 5p minus 25. So it's a nice upward sloping demand curve. As p gets bigger, the quantity supply gets bigger. Has an intercept of negative 25, and the demand function is a nice downward sloping one. Same slope, right? Negative 5 in this case. I mean, same slope. One slope times negative 1. Say magnitude of the slope, and has a intercept of, what is it, 20 or something. And so this is the supply curve and the demand curve. Now notice that I'm taking away, these are just functions of price, right? Of course the demand and supply curve depend on which consumers are around, what the incomes are, what the cost vector of inputs are, but I'm just suppressing that notation, right? We're thinking about this as, given all that stuff, they're floating around in the background as parameters, but what is the supply and demand for that fixed regime, right, of prices and incomes and all that stuff, input prices and incomes. Well, let me take a look at what the let's draw this out a little bit, so you can get a sense of what's going on here. So if we have here's our supply and demand world, our supply and demand area. We have the quantity supplied on the bottom, or quantity demand. The market's quantity on the bottom, and the market price on the top, on the x-axis, on the y-axis, right? And I put in some tick labels, and so we can add in the demand. The demand is downward sloping, right? And it was 500. It was 100 minus 5p, which means that at a price of 20, the demand is 0, right? 100 minus 100. So at 20, we have an intercept on the y-axis, and then at when the price is 0, the demand is 100. Right? 100 minus 0 is 100. So that gives us the 2 points. We just draw a straight line. That's a nice linear demand curve. We're really pretty much only going to deal with linear demand curves in the future. So that's what this demand curve looks like. We can also put in the supply curve. in the supply curve, when the quantity demanded is 0, so this was the supply curve was 5p minus 25, right? So 5p minus 25 means that we have means that if p is 0, when the price is 0, you sell negative 25 units, right? Which means in order to sell 0 units, in order for there to be any supply in the market, the price has to be at least 5, right? Which means the intercept, the y-intercept is 5. And then it just goes up at a rate of, if you increase the price by 1, the quantity supplied gets increased by 5. So we can plug in so this is the market price, P star, and this is the market demand, Q star, or market supply. And the market supply and the market demand equal each other in equilibrium, right? So it doesn't matter if I say supply or demand. And you can solve these two equations, and you get that this is 12.5 here, 12.5, and this here is 37.5. Now, I'm not sure if I drew it exactly to scale. I'm sure that there's a little bit of artistic license here, but approximately it looks right. And of course, I wouldn't rely on your vision. I would just set the two equations equal to each other, and you solve for P star, right? And you plug P star back into either one of them, and you get Q star. And it doesn't matter which equation you plug P star back into. 5 P star minus 25 gives you 37.5. 100 minus 5 P star also gives you 37.5 by nature of having set these, that's how we solve for P star. So of course the Q star equals Q star. So the last thing I want to talk about in this video before we shut it down is consumer surplus and producer surplus. So we talked a little bit about consumer surplus. I never talked about producer surplus, but I bet you can guess what it is, right? It's exactly the same thing just for producers. How much they would have been willing to supply given the price minus how much they actually did, minus what they actually had to supply it at, right? So, so with a single consumer, this was the area below their individual demand curve. We can then talk about market consumer surplus and market producer surplus. And that's just the area below the market demand curve, right? We don't know how it's divisioned between different individual consumers, and we really don't care. We're just saying, consumers got this much surplus from this market. It went to Bobby and Ann and Sally and Joaquim and whatever in different proportions. We don't know. That depends on Bobby and Joaquim's incomes, and it depends on their utility functions and stuff like that, how they aggregate in. But what we know is that the consumer side of the market got a certain amount of surplus. The producers got the opposite, right? I mean, not the opposite, but they got the producer surplus. The producer surplus is, well, they sold it for a price, and those first really efficient firms, the really efficient firms, good technology, was willing to supply some of the output for a much cheaper price, but they got the market price, right? So that's the area above the supply curve and below the price. So what we're going to do is we're just going to look back at what these things look like on our map. So the consumer surplus is this triangle. This is consumer surplus, right? So think about it at each price, at each unit of consumption here, right? So these are all quantities that got consumed. So from 0 to Q star, that's how much got sold, right? That's how many that consumers consumed all of that amount of that good from 0 to Q star. So that's what got sold, and it got sold at the price P star entirely. All of it got sold at the same price. Yet there were some consumers up here, some individual demands, which were willing to pay much more than P star, right? We talked about this when we talked about consumer surplus, so I don't want to go into details. But the idea is that these guys, these elements of demand, whether they are individual consumers or parts of the demand function for each consumer, are willing to pay much higher price than actually got paid, which is P star, right? And so they got some surplus, and the surplus aggregates to this this box, which we're going to call consumer surplus. The exact opposite triangle is the producer surplus, right? Producer surplus, and that's just the space below the price and above the supply curve. Right? Because at each one of these, each one of these firms along the supply curve was willing to supply this first amount, right? The first unit of good, they were willing to supply it at this price here, which is much lower than the price they actually sold it to. So they got some surplus by selling it at a much higher price than they were willing to supply it for. And so the producer surplus is here. Now, how do we calculate the size of these triangles? When you have linear demand, it's very easy, right? So we just need to find the size of a triangle is just the length of the sides times 1/2, right? So consumer surplus is the intercept, so this is intercept, minus P star, that's the length of this side, right? And then times Q star times 1/2. So it's 1/2 intercept minus P star times Q star. And the producer surplus is the same. It's the intercept, but the intercept is lower than the price, so it's 1/2 price minus intercept Q star. Now these look like they should be the same, but remember this intercept is the intercept for the supply curve, and this intercept is the intercept for the demand curve, so they're not the same point. And we'll think more about consumer surplus in a little bit when we talk about the elasticities of these demand and supply functions, and so we can look at figuring out how much of the surplus goes to consumers or producers depends on the relative slopes of the production of the supply and the demand curve, right? So you can see it almost like if I made the supply curve steeper, more of it would go towards the producers. If I made the demand curve steeper, more of it would go towards the consumers. So we'll think about that in detail. That's more of a seminar type question, right? But we can go back and we could just look at numerically what happens. So that's just the same picture. If we look at numerically what happens, we have the same supply. The consumer surplus and the producer surplus in this case are found by just plugging in numbers for what I drew. And notice that they come out to the same number. And they come out to the same number not because of a coincidence, but because the slope was the same, right? I just said the relative producer surplus to consumer surplus depends on the slopes of the demand firms, demand and supply functions. And in this case, they were both -5, or they were 5 and -5. So the magnitude of the slopes was equal. So the consumer surplus equals the producer surplus in this case. So we're going to move on and keep talking about this in the future. But that's a good first. I'm going to just stop the video now, right now.